Hello geometry students, welcome to the continuing series of videos on circles and tangents. And in this video I'm going to discuss one more theorem and then do some example problems. So let's say this is saying the tangent segments from the same external endpoints are congruent. So it always helps to have a picture. So let's say you have that circle here, and then you have this is a tangent. So this is, let's call this line here AB, and let's say this is Q. So given AB is tangent to circle Q at A, alrighty, and let's say you have another tangent CB, and CB is tangent to circle Q at B, at C rather, at C, okay? And since they both intersect at B, this is the common, when we say the same external endpoint, that's this point right here, then we can say that AB must be congruent to CB. Okay. So if you have two tangents that intersect at some external endpoint, then this segment, the tangent segment, is congruent to the other tangent segment. Okay. And then and this is the end of the theorems for this section. I'm going to move on now just to do some problem solving so you can see how some of these problems are done. So in the first one, we have BC is a radius of circle C, and AB is tangent to circle C. Find the value of x. Since it's tangent at circle C, it must form a 90-degree angle. So that's this one right here. So to find x, this is pretty straightforward. We're just really applying the Pythagorean theorem. So x squared plus 96 squared is equal to 100 squared. This comes out to 10,000. Whoops, I got one too many zeros here. (96) squared is 9,216. X squared is then 784, and that means x is the square root of 784, which must be 28. Okay. So that was a relatively straightforward problem. Let's move on. Let's do the next one. This one's slightly different because the triangle has x, and this length here is x plus 16. So you have x squared plus 32 squared is equal to x plus 16, quantity squared. Okay. So this is x squared plus 1024, and this is not, it is absolutely not x squared plus 16 squared. It is x plus 16 times x plus 16. So this is x squared plus 1024. This here is x squared plus 32x plus 256. Okay. When we distribute this out, we get x squared, 32x, and 256. Now notice you have an x squared over here and an x squared over here, so they cancel. And then I'm going to subtract 256 from both sides, and I get 768 equals 32. Divide 32 divide both sides by 32, and you get 24 equals x. Okay. So I'm going to leave this problem here for you to do on your own because it's very similar to this one. Just remember, going from this step here to this step is probably the most important. This is where people make the most mistakes. Okay, so I'm going to do just one of these two. I'll do the odd one, and I'll leave you to do the even one. Now, if you notice here, it says that K and M are points of tangency, so that means this is 90 degrees, and this is 90 degrees. And more importantly, from theorem 10.2 2, we know that this length and this length must be equal to each other. So therefore, 3x squared minus 10 is equal to 17. 3x squared is equal to 27, adding 10 to both sides. X squared is equal to 9 by dividing 3. And that means x is equal to the square root of 9, which in this case is 3 or negative 3. Both of them work, okay, because the square root of 9 is equal to 3, and the square root of 9 is also equal to negative 3. And when you substitute this number back into the original expression, it also works. So if you put negative 3 in for x, you do in fact get 17. So both of these, are correct answers. Okay, so the problems in this lesson are not meant to be difficult. I think it's just proving that something is always true is always the big challenge. As always, if you have a hard time, ask your teacher. Keep working at this. It'll come to you. Have a wonderful day.